Hi kids, so this video is for class 9 student. We'll be solving numericals from Concise physics. This is Upthrust in fluids, Archimedes principle and floatation exercise 5C. Okay, class 9. Let us look at the first sum. We have already discussed the entire chapter. You can see the playlist or you can see the description box. Okay. Number 1. A rubber ball floats on water with its 1/3 volume outside water. What is the density of rubber? See, you have a rubber ball kept inside water in such a way that 1/3 of its part is outside water. They need the density of the rubber. Now look carefully. Let the total volume, suppose V meter cube, okay? Then volume outside water is 1/3 of V, that is V by 3. Volume inside, immersed inside water is V minus V by 3. 3 taken LCM, 3V minus V. That's 2V by 3. Very easy. Now we have a relation. Remember? Volume and density. Volume of the immersed part of the solid by total volume. This is immersed part, this part, okay, by total volume is equal to density of the solid by density of the liquid in which it is kept. Yes or no? Just substitute the value. So volume immersed is 2V by 3, 2V by 3. Total volume is capital V. Density of the solid, we don't know. Density of the liquid, since it's water, SI system, 1000 kg per meter cube. This V cancels out. So 2 by 3 equals to density of solid by 1000. So density of solid is 1000 multiplied by 2 by 3. So that's how much? 2000 by 3. That's 666.67 kg per meter cube. Done. They have given the answer as 667 kg per meter cube. They have rounded it off, 667 kg per meter cube. Done. Pretty easy. Just use this relation. Now let us do sum number 2. Now let us look at number 2, what they have told. A block of wood of mass 24 kg floats on water. The volume of wood, the total volume of the wood is given as 0.032 meter cube. Find, number 1, A, the volume of the block below the surface of water, small v, immersed inside the water. Number B, the density of wood. They've asked these two things. Now, first thing, mass and volume is given. We know the relation between mass, volume and density. Density, we'll do this part first. Density equals to mass by volume. That's 24 by 0.032. Yes or no? Just simplify it. This is 24 into 1000 by 32. 1 place, 2 place, 3 place. So 1000 comes. 8, 3 times, 8, 4 times. For 1 time, 250. That's 750 kg per meter cube. Let me see. That should be the answer. Yeah, they have given it 7.5 into 10 to the power 2 kg per meter cube. Same thing. Okay. Now what they asked. Volume of the wood immersed. Yeah. Volume of the block below the surface of water. Very easy. We just did a relation. Volume below the surface of water by total volume. Density of the solid by density of the liquid. Yes or no? Simplify. Total volume 0.032. Volume density of the solid is 750 by 1000. 3 times, 4 times. 250 3 times, 250 4 times. Solve it. So volume is 3 into 0.032 by 4. Yes or no? Now remove this decimal. So we'll divide by 1000 for 1 time, for 8 time. Just solve it. So this is 24 by 1000. That is 0.024 meter cube. This much volume of the block will be inside water, below the surface. Yeah, they've given the answer as 0.024 meter cube. Done. Pretty simple. We use the same relation over here, and this is, we know this from class 7, I think. Density equals to mass by volume. Now let us do number 3. Now look at number 3. A wooden cube of side 10 centimeter has mass 700 gram. What part of it remains above the water surface while floating vertically on the water surface? Which means you have, suppose, water in the container. You have a cube. Okay, you have a cube. A portion of the cube is inside water and the portion is outside water. Okay, they need, and they've given the side of the cube is 10 centimeter. This total is 10 centimeter. So how much part is outside water? Yeah, what part of it remains above the water surface while floating vertically on the water surface? Okay, and the mass is given to us. Mass is 700 gram. Anything else? No. Chalo. First of all, look over here. We can get the density of the wooden block by finding the volume. See, volume is what? Volume of the cube is side multiplied by side multiplied by side. That is 1000 centimeter cube. You have mass, we have volume. Density of the solid is mass by volume. Yes or no? Gram per centimeter cube. That is 0.7 gram per centimeter cube. Done. Now, look carefully. Volume of the body immersed in water by total volume is equal to density of the solid by density of the liquid. Now, how much volume is inside water? We don't know. Volume outside water, that is 1000. Okay. Density of the solid is 0.7 and density of the liquid, which is water, will be 1 gram per centimeter cube. So that's 1. So volume 1000 into 0.7 is 700 centimeter cube. So this much volume is inside water. So the volume of the wood, volume of this block outside water, volume of block outside water is 1000. That's the total volume minus volume inside water, which is 700. Now that's 300 centimeter cube. Yes or no? Now look over here. The portion which is outside water, if you look carefully, that looks like a cuboid whose length is 10, breadth is 10, but the height we don't know. Yes or no? Suppose h, this much height is outside water surface. Then volume of the portion which is outside water will be length multiplied by breadth multiplied by height. That will be equal to 300, which means h will be 3 centimeter, which means 3 centimeter will be outside the water surface and 7 centimeter will be inside. Yes or no? What they have given? Yeah, 3 centimeter height. That much will be outside water. Getting it? This portion, see. which was outside water. That looks like a cuboid, isn't it? We have length, we have breadth, we don't have the height. Chalo, we'll do number 4 now. Now look at number 4. A piece of wax floats on brine. What fraction of its volume is immersed? Now look carefully. Have they given something? Yeah, they have given the density of wax is 0.95 gram per centimeter cube, and density of brine in which it is kept, the fluid, it's 1.1 gram per centimeter cube. Yes. What they have asked? What fraction of its volume is immersed? Now look carefully. We have the relation. Volume of the portion immersed by total volume is equal to density of wax by density of brine, the liquid. So this is 0.95 by 1.1. Yes or no? That's, when you solve it, this is 8 point, let us solve it, wait. This goes 100, this goes 10. So 95 by 11. 8 times, isn't it? 88. Then 6 times. Yes or no? 8.6 becomes, yeah, keep it till one place of decimal, 8.6 by 10. So that's 0.86. Yes or no? This is your, this much part, is, so what, see, small v is 0.86, capital V, which means 0.86 part of its total volume will be immersed inside water. Yes or no? Yeah, they've asked that only. What fraction of the volume is immersed? Fraction of the volume immersed is 0.86. Okay. This was number 4. Now let us see number 5. Now look at number 5. If the density of ice is 0.9 gram per centimeter cube, what portion of an iceberg will remain below the surface of water in a sea, and density of sea water is given as 1.1 gram per centimeter cube? Similar to number 4. They've asked what portion of an iceberg will remain below. Very easy. Volume of the ice immersed in water by total volume. They want this thing only. What portion is immersed? That is density of ice by density of water, sea water. That's 9 by 11. Which means this much portion will be submerged inside water. Yeah, they're given as, the answer is 9 by 11th or 0.818 part. That's your answer. Done. Pretty simple. Now let us look at number 6. Now look at number 6, what they have told. A piece of wood of uniform cross section and height 15 centimeter floats vertically with its height 10 centimeter in water and 12 centimeter in spirit. So we have two cases. In water, when you keep it in water, then what happens? Just look carefully. A piece of wood of uniform cross section and height 15, the total height is 15 centimeter, floats vertically with its height 10 centimeter in water. So this inside water is 10 centimeter. So outside water will be 5 centimeter. No doubt in that. This is your water. Now the same piece of wood, when it is kept in spirit, then 12 centimeter is inside water. See, a piece of wood of uniform cross section and height 15 centimeter floats vertically with its height 10 centimeter in water and 12 centimeter in spirit. So you have another liquid, okay, spirit, and in that when you keep the object, then you have 12 centimeter inside the liquid. Okay, they're told find the density of wood and spirit. Find the density of this wood, density of wood they have asked, and density of spirit, in which we have kept it over here. Now look carefully. What I'll do, this is water. So if you look carefully, if I take the area of cross section, area of cross section of this wooden block, suppose A, then total volume will be area into height, cross section area into height, that is 10. Volume inside water, again cross section area into height, O. In the first case, total volume, the total height is 15, isn't it? In the second case, volume inside water, cross section area multiplied by height. Volume of a body with uniform cross section area is area of cross section into the length or the height. Okay, now we know small v by capital V equals to density of the solid by density of the liquid. Now small v, volume inside water, A into 10. Capital V, total volume, A into 15. Density of the wood, we don't know. Density of the liquid, this is water. So 1 gram per centimeter cube. So A cancels out. This is 2 by 3. So 2 by 3 equals to rho S, which means density of the solid will be 0.667. Density of wood will be 0.667 gram per centimeter cube, or you can leave it like 2 by 3 gram per centimeter cube also. Yeah, they're given it as 0.667 gram per centimeter cube. Now what they have asked, the density of the spirit. Same logic, same calculation. Look over here. Over here, volume inside water is cross section area into 12. Total volume is cross section area into 15. Yes or no? Density of the solid, we know, 2 by 3. They've asked for density of the spirit, which is use the same logic. See, small v by capital V, density of the block by density of spirit, we don't know. Yes or no? A cancels out, 3 1 time, 3 5 times, 2 1 time, 2 6 times. So density of the spirit will be 5 by 6, 8 times, so 0.8, 48, then 26, 3 times. So just divide it, you will get the answer as 0.833 gram per centimeter cube. And that's my answer. Done. Same logic we have used. And remember, volume of a body with uniform cross section area is area of cross section multiplied by the length or the height. Okay? Sure. We'll do number 7 now. Look at number 7. Similar to the previous one. A wooden block floats in water with 2/3 of its volume submerged in water. Volume submerged is 2/3 of total volume. Suppose the total volume is capital V. Okay. A wooden block floats in water with 2/3 of its volume submerged. Calculate the density of wood, the solid. Okay, density of the solid, density of wood. And when the same block is placed in water, sorry, not water. When the same block is placed in oil, when you placed it in oil, 3/4 of its volume is immersed in water. So volume submerged or inside water, inside oil is 3/4. That is 3/4 of capital V. Done. And they have asked for calculate the density of oil. Very simple. In the first case, see, small v by capital V equals to density of the solid by density of the liquid. Small v is 2/3 of V. Okay, total volume is V. Rho S we don't know. Rho of the liquid, which is water, 1000 kg per meter cube. Yes or no? Water, we know the density. Yes, this cancels out. So this becomes rho S becomes 2000 by 3. That is 667 kg per meter cube after rounding off. Yes or no? Now, let us see this one. When it's kept in oil, volume submerged is 3/4. Again, small v by capital V is rho of S by rho of oil. Now, small v is 3/4 of capital V. Rho of S is 667 by this is rho of oil, we don't know. We need to calculate that. V cancels out. So rho of oil is 667 multiplied by 4 by 3. Once you solve it, rho of oil comes over here, 4 goes over there, 3 comes down in one step. Now you calculate this. Okay, this is how much? 7 4 is 28, 24 divided by 26, 24 divided by 26 by 3, 3 8 times 24, then again 3 8 times 24, 28, 3 9 times, then 1 by 3 kg per meter cube. That's my 889 they have written. Okay, okay. This is 889 whole 1 by 3 kg per meter cube, and that's my answer. If you put this now, I think that 889 will come. This value. Look carefully. Density of oil will be, instead of 667, I'm putting 2000 by 3. Okay, into 4 by 3. Now it will still come in fraction. You know, they've rounded it off. So the answer is 889 kg per meter cube. Now let us look at number 8. Now look at number 8. The density of ice is 0.92 gram per centimeter cube, and that of seawater, density of seawater, it's 1.025 gram per centimeter cube. Find the total volume of the iceberg. They need the total volume when its volume 800 centimeter cube is above water. Volume above water is 800 centimeter cube. So volume inside water will be capital V minus 800. That's quite logical. Total volume minus volume outside water. So this much is immersed in water. Yes or no? Find the total volume of the iceberg. They want capital V only. Let us solve it. We know small v by capital V is equal to density of the solid, which is ice in this case, by density of the liquid, which is water, seawater of course. Then small v is this thing, volume inside water, capital V minus 800 by V is equal to 0.92 by 1.025. Just substitute the value and now you solve it. So that's, this goes over there, this comes over here. So 1.025 V minus 800 is equal to 0.92 V. Yes or no? Open the bracket. So 1.025 V minus 800 into 1.025 is equal to 0.92 V. Now this we can write as 1.025 V minus 0.92 V is equal to 800 multiplied by 1.025. Yes or no? Then this is 1.025 minus 0.920. Okay, that becomes 0.105. That's 0.105 is equal to 800 multiplied by 1.025. We missed V over here. So what is V? 800 into 1.025 by 0.105. This is the total volume. Okay, which when you solve, I'm not solving it, just solve it on your own. This should give as 7809.5 centimeter cube. Multiply these two and divide by 0.105. Clear? You will get this answer only. The process is this. Okay. Chalo. We'll do the last sum, number 9. See number 9. A weather forecasting plastic balloon of volume 15 meter cube contains hydrogen of density 0.09 kg per meter cube. The volume of the equipment carried by the balloon is negligible compared to its own volume. The mass of the empty balloon is 7.15 kg. The balloon is floating in air of density this. Calculate. Number 1. The mass of hydrogen in the balloon. Now, density equals to mass by volume. So, mass equals to density into volume. Simple. Density of hydrogen is 0.09. Volume will be equal to the volume of the balloon in which it is kept. That's 15 meter cube. 9 into 15 is 135. So, that's 1.35 kg. That's the mass of hydrogen in the balloon. Done. Very good. Number 2. The mass of hydrogen and balloon. Very easy. Mass of hydrogen plus balloon. What do we do? 1.35 plus they've given the mass of mass of empty balloon is given as 7.15. So we add it, 40, 50, that's 8.50 kg. Done. Sure. The total mass of hydrogen balloon and equipment, if the mass of equipment is x kg. Now number 3, mass of hydrogen plus balloon plus equipment is 8.50 plus x, because they have told us that the mass of the equipment is x kg. Yes or no? The 4th one, the mass of the air displaced by balloon. Now, the weight of the air displaced by balloon is nothing but upthrust. Yes or no? So, this weight will be equal to volume into V rho G. Yes or no? Which is mass will be equal to V into rho. So this was weight. We removed G. So whatever is left is mass. They've asked mass, the mass of the air displaced by balloon. So mass of the air displaced by balloon is volume of the air displaced by the balloon, which is 15 meter cube. Yes or no? And density of air, which is 1.3. Yes or no? So this will be 15 into 1.3. 15 one time is 15. 15 three times is 45. So 4.5. So 15 plus 4.5 is 19.5 kg. Yes or no? Look carefully. The mass of the air displaced by balloon. So the weight of the air displaced by the balloon is equal to the upthrust. Upthrust will be V into rho into G. V is the volume of the balloon because that much volume of air will be displaced. Yes or no? Now number 5. The mass of the equipment using the law of flotation. According to the law of flotation, we can say the weight of the air displaced, is equal to total weight. Total weight means the weight of the balloon, equipment, air, everything, which means mass of the air displaced will be equal to mass of balloon plus mass of hydrogen plus mass of equipment. Yes or no? Equipment. Let's just solve it. Mass of air displaced is 19.5. Mass of balloon is, we had mass of balloon. Yeah, mass of balloon plus mass of hydrogen is 8.50. These two together, 8.50. Plus mass of equipment, so that's 19.5 minus 8.5. So mass will be 11 kg. So this is the mass of the equipment using the law of flotation. Done. Weight of the air displaced is equal to total weight. So mass of the air displaced is equal to mass of the balloon plus mass of hydrogen plus mass of equipment. Use this concept. Done. Chalo, we'll keep it till here. If you like the video, do subscribe and share with your friends. Till then, take care and be safe.